Hello everyone, welcome to MathWorld. This video is to discuss Cambridge International A-Level Mathematics Paper 3, which is a pure mathematics 3 for May-June 2019, and the code is 9709/31. So let's move on to question number 1. For question number 1, use the trapezium rule with 3 intervals to estimate the value of this integration. Okay, so now for the trapezium rule, even though this question has been removed from the syllabus for year 2024 exam, but I still solving this so that you get the idea what is the trapezium rule. So basically for trapezium rule, look at the x, the limits 0 to 3. So here I will label 0 to 3, but since there are 3 intervals, that means it will be 4 ordinates. Okay, 4 ordinates means that you will have another 2 points here. So from here, I know that the h, which is the width, that will be 3 minus 0. Okay, 3 minus 0 over 3 because of the intervals. Therefore, it will be 1. So the width of the ordinates will be 1. Okay, that means here is 1 and 2. So I will label the x0 as 0 naught. I mean the 0 as x0. Then the x is x1 as 1, then the 2 is x2, then the 3 will be x3. Okay, then according to the trapezium rule, integrates from 0 to 3, modulus of 2 power x minus 4, this is going to be h over 2, then y0 plus y3. Okay, the first y and last y, because you are given x0 and x3, that's why y0 and y3, and plus 2 times the rest of the y values. Then you will get y1 plus y2. Okay, this is the trapezium rule formula. So now since our h is 1, therefore you are getting half. Then the y0 is basically this y value when the x is x0. So it will be modulus of 2 power 0 because your x0 is when the x is 0, right? So therefore minus 4 here, and then plus y3 will be 2 power 3 minus 4, and plus double of the rest, that will be 2 power 1 minus 4 because x1 corresponds to 1, then plus modulus of 2 power 2 minus 4. Okay, then from here the modular sign will be giving you a positive value. So the first one will be 2 power 0 minus 1, 2 power 0 minus 4, that is minus 3. So modulus of minus 3 plus modulus of 4 plus double of modulus of negative 2 plus 0. Okay, and remember the modulus means absolute value. So just ignore the negative sign if you are getting modulus of negative value. So therefore you will be getting 3 plus 4 plus 2 times, now the whole bracket here is basically just 2. Okay, so at last you will be getting 11 over 2. So this is the trapezium rule. Okay, now for question number 2, showing all necessary working. Solve the equation ln of 2x minus 3 equals to 2 ln x minus ln of x minus 1. Give your answer equal to 2 decimal places. Okay, so from here, firstly, I notice that there are 2 ln on the right side. So before I combine the ln, make sure the coefficient for the ln is 1. Okay, so I have 2 here. Therefore, we have a formula a ln b equals to ln b to the power of a. So which means I will move up the 2. So this means ln x squared minus ln of x minus 1. And then now, since you have 2 ln there, right? So ln a minus ln b, that is ln of a over b. That means now here I will be getting equals to ln x squared over x minus 1. So I will rewrite my left hand side, and now I can cancel off the ln from both sides. Therefore, you are getting 2x minus 3 equals to x squared over x minus 1. And now here, to get the answer equal to 2 decimal places, solve means basically you need to find the unknown. What is your x in the question? So for this question, the easiest way is just move up the denominator. So when move up means that it is times. So then I will be getting 2x minus 3 times x minus 1, that is x squared. Okay, and then now for the left hand side, just do expansion, multiply 1 by 1. So I will be getting 2x times x, it will be 2x squared. 2x times minus 1 is minus 2x. Minus 3 times x, you get negative 2x. Minus 3 times minus 1, that is plus 3. And don't forget, you have a x squared on the left side. So move this term to the left side. Right, you have the x squared on the right side. So move it to the left side. Then I will be getting minus x squared. Then equals to 0. And now here, I will simplify this to get a quadratic equation. So first and last term plus together, that is x squared. And then the second and third term, when you plus together, that is actually minus 5x. Then followed by plus 3 equals to 0. This is a quadratic equation. And since the question asking for 2 decimal places for the answer, then I will refer to the quadratic formula, which is ax squared plus bx plus c equals to 0. Then your x is going to be minus b plus minus square root of b squared minus 4ac over 2a. Okay, that means now here I will write down my a, b, c first. My a is 1, b is minus 5, and then c is 3. Then from here, your x is going to be minus b plus minus square root of b squared is minus 5 squared. Then minus 4, a is 1, c is 3. Then over 2a. Okay, then from here you get 5 plus minus. Now, 5 squared is, negative 5 squared is 25. So then 25 minus 12. 25 minus 12, that is going to be 13. Then over 2. Then from here, you will just calculate the value. Okay, the first value is counted using minus, therefore you are getting 0.70, 2 decimal places, and the next value is counted using the plus, then you will be getting 4.30. Now, you are getting 2 values here, but then when you look at the question, okay, you need to solve. Right, now, since we have ln here, okay, make sure ln of positive value, everything is positive. So, now, which means, okay, when the x equals to 0.7, the right hand side, you see here, for this equation, ln 2x minus 3, left hand side, ln 2x minus 3. So this is going to be ln, so 2 times 0.7 minus 3. This is a negative value, right? 1.4 minus 3 is actually negative 1.6. So this is undefined, right? So ln cannot be negative. Therefore, the x cannot be 0.70. So our x is only 4.30 because I noticed that when I substitute this x goes to 4.30 into left side, so this one will be greater than 3, okay, when you replace. And then here is positive, and then this is also positive. Alright, so that's all for this working. Okay, now for question number 2, find the gradient of the curve at the point where with coordinates 1, 3. So this gradient is basically dy over dx. That means now to solve this, I need to perform the implicit differentiation because you cannot separate the x and y completely. Okay, so for the first term, because now gradient is basically dy over dx, which means you differentiate y with respect to x. So I will differentiate term by term. So firstly, differentiate x cubed with respect to x. So just differentiate as usual because it's the same variable. Then you will be getting 3x squared. Now for the second term, be careful with this. This is 3x, another one is y squared. So this is basically the products rule. So I have to differentiate using products rule, whereby d over dx uv, that is uv prime plus vu prime. Okay, so it means that my u is 3x, my v is y squared. So now here, keep the formula, keep the u, means that keep the 3x. Well, when you differentiate y squared, and now I'm differentiating with respect to x. So just for information, we have another formula. Differentiate function of y with respect to x. That is going to be differentiate function of y with respect to y, then you times dy over dx, which means now when I differentiate y squared with respect to y, that is going to be 2y, and then times with dy over dx by referring to the orange color formula. Then that is my v prime. Plus, now refer back to the products rule, keep the v, so means keep the v y squared and differentiate 3x, that is going to be 3. Okay, minus, now lastly, when you differentiate y cubed with respect to x, use this formula, right? The implicit differentiation. So as usual, when you differentiate y cubed, that is 3y squared. Because when you differentiate with respect to y, it is a same variable, so just direct differentiate. And then don't forget to times the dy dx at the back. And right hand side will be 0. Okay, so from here, I need to find out what is the gradient given the point. So when the point, this x is given, and then the y is also given. So I will just direct write at 1, 3. That means my x is 1, my y is 3. Okay, then from here, just replace 3 times 1 squared plus 3 times 1, then 2 times 3, because the y is 3, dy dx, plus 3y squared, so 3y squared minus again 3y squared dy dx equals to 0. Okay, so from here I will be getting 3 plus. Now, when you do the expansion, this is 3, this is 6. So 3 times 6, 18. Then it is 18 dy over dx. Then now here, 3 times 3 squared, that is 27. Same goes to the next term, 27 dy over dx, that equals to 0. So from here, when I simplify, plus 18 dy dx minus 27 dy dx, that is minus 9 dy dx. Then here, 3 plus 27, that is 30. Positive 30, when you move to the other side, it becomes negative 30. So obviously the minus can be cancelled off. Therefore, my dy dx is basically 30 over 9. That is 10 over 3. Okay, so done for the question number 3. Okay, for question number 4, by first expressing the equation cot theta minus cot of theta plus 45 degrees equals to 3 as a quadratic equation in tangent theta. Solve the equation for theta between 0 and 180 degrees. So now, cot theta minus cot of theta plus 45 degrees equals to 3. We know that cotangent theta is 1 over tangent theta. So I change to tangent theta first. Now, cotangent of theta plus 45 degrees, it will be 1 over tangent theta plus 45 degrees. That is 3. Okay. Now, for the first term, I will rewrite. But for the second term, use the formula. So we have tangent A plus B. That is tangent A plus tangent B divided by 1 minus tangent A tangent B. That means this is going to be 1 divided by, okay, tangent theta plus tangent 45 degrees, that's my numerator, over 1 minus tangent theta tangent 45 degrees, according to the formula, the addition formula. That equals to 3. Okay, so now I will simplify first. This is going to be 1 over tangent theta minus 1 over tangent 45 degrees is basically 1. So here I will change to 1. This one I change to 1. That means here you will be getting tangent theta plus 1 over 1 minus tangent theta times 1. That is tangent theta. Okay, now we have a formula. if A divided by B over C, that is same as A times C over B. That means here is my A, this is BC. So at last, I will be getting AC over B. Means that this C, you move up. Okay, so I will be getting 1 over tangent theta minus, move up the 1 minus tangent theta, then over tangent theta plus 1 equals to 3. Okay, and now the question says you need to get the quadratic equation. So from here, right, to get the quadratic equation, the easiest way is times the whole equation by the denominators. So here I have two denominators. So multiply with tangent theta and tangent theta plus 1 for the whole equation. So it means that the first term, I have tangent theta plus 1. And then for the second term, because you have tangent theta plus 1 already, therefore you have to times with tangent theta. So for the right hand side, just multiply with these two terms. Okay, now in order to get the quadratic equation, just do expansion. So I will be getting tangent theta plus 1. Now here, just do expansion, just multiply together with the minus sign. So I will be getting minus tangent theta plus tangent squared theta. Then for the right side, still expansion, right? So you will be getting 3 tangent theta squared, because tangent theta times tangent theta is basically tangent squared theta. Then plus with 3 tangent theta. Okay, so now to get the quadratic equation, look at here. This is 1 tangent squared and this is 3 tangent squared. So since the 3 is greater than 1, therefore I will move all the terms to the right side. So, and at the same time, I will simplify. Therefore, 3 tangent squared theta minus 1 tangent squared theta, you will be getting 2 tangent squared theta. Okay, and then now, the next one is going to be this term. So you move it to the other side and then combine with the 3 tangent theta. So since you move the minus tangent theta to the right side, it becomes plus, therefore it becomes 4 tangent theta now. Okay, I miss out one, I overlook one term. Look at here. This one no need to move because, okay, look at here. Look at the left hand side. Right, these two can be cancelled off. Okay, so it means that I will just need to rewrite the right hand side, the term on the right hand side. That is the 3 tangent theta. And then the plus 1 move to the other side becomes minus 1. So this is my equation, my quadratic equation in terms of tangent theta. After this, okay, solve the equation for theta between 0 and 180 degrees. So now here, this quadratic equation cannot be factorized. Therefore, I have to use the formula. Let my A be 2, my B is 3, my C is minus 1. Use a quadratic formula. But quadratic formula supposedly AX squared. So now your X becomes tangent. So now, here I will write tangent theta equals to minus B, so minus 3, plus minus square root of B squared minus 4AC. Then over 2A. Okay, then from here, you will be getting minus 3 plus minus square root of 17 over 4. So at last, okay, I will be getting negative 1.780776. This is counted when you use minus, the minus square root 17. Okay, then when you choose plus square root 17, that is going to be 0.280776. Now, given the theta between 0 and 180 degrees, that means that will be the angles in first two quadrants. Right, so now here I will split it into two terms. Tangent theta is negative value, and the other one, tangent theta, is positive value. So now tangent theta is negative value means that the angle is in second quadrant. So then I need to find out what is this basic angle. So I will write basic angle equals to inverse tangent 1.780776. That is going to be 60.7. So here I get 60.7. But then my theta is basically the major angle. So now my theta is going to be 180 minus 60.7 degrees. Then you will be getting 119.3. Okay, now for the next one, whereby the theta, tangent theta is positive, that means that is in the first quadrant. So I will just write basic angle, that is 15.7 degrees. So hence my theta is going to be 15.7 degrees. So that's all for the solution of this question. Okay, for question number 5, first part. Differentiate 1 over sine squared theta with respect to theta. Okay, so first of all, the sine squared theta in the denominator will be moved up. Okay, so I will just write d over d theta 1 over sine squared theta. This is same as d over d theta sine squared theta to the power of -1. So we have a formula here, a power m, and then with another degree outside. Basically, our new degree is m times n. So it means that the 2 times -1 becomes -2. That is the degree. So I can just take up the degree. It becomes sine theta to the power of -2. Okay, and now to differentiate this, we have another formula. To differentiate function with power n, right? This is what we call as power rule. You bring down the n, rewrite the function, then the degree -1. Now, followed by differentiating the fx to get f prime x. So from here, I will get -2, then rewrite the sine theta. Okay, the degree you -1 means that -2 minus 1 becomes -3. After that, you differentiate sine theta. So when you differentiate sine theta, that is going to be cos theta. Okay, then from here, since the power is -3 for sine theta, I will move it down. Therefore, I will just write -2 cos theta over sine theta cube. So you can express in this form, or probably you can move up the sine cube, up to you, because we know that the 1 over sine theta is basically cosec theta. Okay, so then from here, I will just write this is basically -2 cot, or okay, power 3, right? Sine and cos, I can simplify again. So then from here, I will say that it is basically -2 cos theta over sine theta, then 1 over sine theta, sine squared theta. Okay, so you can express in any forms. Then cos over sine is basically cotangent. So this is simplified into -2 cot theta. Then 1 over sine, it will be cosec. So cosec squared theta. So you can either leave your answer in this form or the last form. So this is the differentiation. Now question number 2, part 2. Okay, question part 2. The variables x and theta satisfy the differential equation. X tangent theta dx d theta plus cosec squared theta equals to 0 for theta between 0 and half pi, and the x is greater than 0. It's given that x equals to 4 when theta equals to 1 over 6 pi. Solve the differential equation obtaining the x in terms of theta. So from here, I will rewrite the question first. X tangent theta dx over d theta plus cosec squared theta equals to 0. So first of all, to solve this differential equation, we need to separate the variables. Okay, which means x tangent theta dx over d theta equals to negative cosec squared theta. And then now by looking at the dx d theta, since your dx is a numerator, that means whatever function with the x should be on the left side, which means the functions with the data should be on the right side. Okay, so means that now I will write x dx equals to minus cosec squared theta. This tangent this tangent theta, because of the theta there, will be moved to the other side. So when you move, it becomes divide, because initially multiply. So divide by tangent theta, and then the d theta move up, then here will be d theta. And now, once you have separated the variables, do not forget to integrate both sides. Okay, so now for the right hand side, you need to integrate negative cosec squared theta over tangent theta. So it is same as the previous. See here, because we know that the over tangent theta, this is same as negative cosec theta times 1 over tangent theta. So we know that 1 over tangent theta is basically cotangent. Okay, so here I will write this is basically negative cosec squared theta cot theta d theta. And we have proven the differentiation just now. See, when you differentiate 1 minus 1 over sine squared theta, you are getting negative 2 cot theta cosec squared theta. So which means when we integrate, right, when we integrate the right side here, you will be getting the left hand side. Okay, so from here I know that, right, so here x squared equals over 2. When you differentiate left side, you get this result. Now for the right hand side, I know that from, probably I will just write here, okay, from first part, from part 1, okay, differentiate 1 over sine squared theta. That is negative 2 cot theta cosec squared theta. So we know that the integration is the reverse process of differentiation. That means when I integrate the right side with respect to theta, the answer is going to be left hand side, which is 1 over sine squared theta plus c. Okay, but then when you look at the question over here, this is negative and cosec squared cot. So negative cot and cosec squared. So means that the 2 is extra. So I have to move the 2 to the other side. In other words, the integration is basically negative cot theta cosec squared theta d theta. By moving down the 2, that will be half of 1 over sine squared theta. Then I plus k, for example. Okay, then from here, I will just direct replace this result into my into my differential equation. So I will rewrite the question, integrate x dx, that is integrate minus cot theta cosec squared theta. So for the left hand side, when you integrate, that is going to be x squared over 2. Then for right hand side, just copy this. Now basically for left hand side, because this is the integration without limits, you should plus c, and then right hand side you plus d. So the c and d can be just simplified into our k here. Okay, because all of these are arbitrary unknown, arbitrary constants. So that is going to be half 1 over sine squared theta plus k. Okay, and now here I can just simplify, or no need to simplify first, just replace first. It doesn't matter. X is 4, theta is pi over 6. So x is 4, theta is pi over 6. So by replacing these two values, I will be getting 4 squared over 2 equals to 1 over 2 times 1 over sine pi over 6, then squared plus k. Okay, so for the left hand side, 4 squared over 2 is basically 8. Then half, right? So sine pi over 6 is basically sine 30. Sine 30 is half. So 1 over half. You square it. Then plus k. So 1 over 1 divided by half is basically 1 divided by 1 over 4. So you move up, becomes 1 over 2 times, okay, so it will be 1 over, half times 1 over 4. That is 1 over 2. Okay, so that means this is going to be 1 over half, because you can just direct cancel. See here, cancel, right? Then here I will just get plus k. So 1 over half is basically 2. Therefore, my k is going to be 6. Okay, then now substitute this k value into the previous solution. So I will just rewrite my solution here. I will be getting x squared over 2 equals to 1 over 2 sine squared theta plus 6. Now let's look at the question. The question says you need to get x in terms of theta. So it means that I need to get the x as a subject. So in other words, to get the x as a subject, I shouldn't have over 2 here. So I have to times 2 first. So when I times 2 to the whole equation, you'll be getting x squared equals to 1 over sine squared theta plus 12. Okay, now my x is square root of 1 over sine squared theta is basically cosec squared theta plus 12. Okay, now here, supposedly when you, here I should write plus minus because you eliminate the square. Now look at the condition. Okay, you are given x is greater than 0, right? So just write here, given x is greater than 0. Therefore, we know that the square root value always positive. So since this whole square root value is positive, okay, in order to get positive x, I must choose the plus sign. Therefore, we shouldn't include the negative value for the x. So my x is going to be square root of cosec squared theta plus 12. So that is my solution. Okay, so done for this question. Now next question, number 6, first part. By first expanding sine 2x plus x, show that sine 3x equals equivalent to these two terms. So here I will start with left hand side. Sine 3x is basically sine 2x plus x. And then now, to get this expansion, we need to refer to the addition formula, sine A plus B. That is going to be sine A cos B plus cos A sine B. Okay, then here I will be getting sine 2x cos x plus cos 2x sine x. And now when you look at the answer here, there's no cos, which means you need to simplify, or you need to change the cos 2x into another term, into sine x, right? And now here I have sine 2x. So we have sine 2a, that is 2 sine a cos a. This is the double angle formula. So now I will be getting 2 sine x cos x multiplied with cos x, and then plus the cos 2x, right? Cos 2x, we have cos 2a, we have 3 forms. Okay, so I better write down all 3 forms here. So cos 2a, we have cos square a minus sine square a, that's the first form. Or it could be 2 cos square a minus 1. It could be 1 minus 2 sine squared a. So by looking at the given answer here, okay, or given identity, there's no cos. Therefore, I must choose the last form. That is going to be 1 minus 2 sine squared x. Then you multiply with sine x. And now here you do expansion, right? So this one just do expansion. These two just combine. So I will be getting 2 sine x. Cos x times cos x, it will be cos square x. And then plus sine x times 1, that is sine x. Sine x times negative 2 sine square x, that is negative 2 sine cube x. Okay, now again, I have extra term, which is a cos square x here. This is extra. So then we need to change to identity, which is sine square A plus cos square A is 1. Therefore, my cos square A, okay, keep this term on the left side by moving the sine square to the other side, which means cos square A is 1 minus sine square A. Okay, and then you will be getting equals to 2 sine x, then 1 minus sine square x, and plus sine x minus 2 sine cube x. And then now here, just do expansion. So 2 sine x times 1 to get 2 sine x, then multiply with minus sine square x. That means I will be getting 2 sine x and minus 2 sine cube x plus sine x minus 2 sine cube x. Then now, here when you look at the answer, we start with 3 sine x first. So which means now you just simplify the term with sine x, right? Sine x degree 1, that is going to be 3 sine x, and then followed by minus 2 sine cube minus 2 sine cube, that is minus 4 sine cube x. So shown the identity. Okay, now second part, hence means use the previous answer, showing all necessary working, find the exact value of this integration. So now I will rewrite first. Okay, sine 3x right? Then from here, we need to integrate sine cube x. So I get the sine cube x as a subject. Means that firstly, I will move this minus 4 sine cube x to the left side, and this sine 3x will be moved to the right side. So that I will be getting 4 sine cube x equals to 3 sine x minus sine 3x. Then the 4 will be moved down. So sine cube x equals to 1 over 4 bracket 3 sine x minus sine 3x. Okay, that is my expression of sine cube x before I substitute into this integration. So now I integrate from 0 to 1 over 3 pi sine cube x. That is 1 over 4 integrate from 0 to pi over 3 sine x minus sine 3x. So now here, just rewrite. Now when you integrate 3 sine x, that is going to be negative 3 cos x. Because when you differentiate cos x, it will be negative sine x. And then the negative sine 3x, it will be negative of negative cos 3x over 3. Because of our formula over here. Okay, the formula is basically integrate sine mx plus b dx, that is negative cos mx plus b over m plus c. Okay, then now replace the x by pi over 3 first. So I will get 1 over 4 negative 3 cos pi over 3. Now look at here, this minus minus is basically a plus. So I will just write plus. Then this over 3 can be taken out. So 1 over 3 cos. Now 3 times pi over 3, that will be pi. Okay. And then minus, when the x is replaced by 0. So I get negative 3 cos 0. Then minus minus is a plus 1 over 3 cos 0. Okay. Then from here, now the question says exact value. Okay, exact value means no decimal. So therefore, I will get 1 over 4 minus 3. Now cos 1 over 3 pi is basically half. Okay, cos pi is minus 1. Cos 0 is 1. So here is 1. That means I will be getting plus 1 over 3 times minus 1. So then, don't forget, there's a minus outside. The minus you bring in, minus minus is a plus, and this minus will times to the next term, that will be minus, right? So here I will get plus 3 minus 1 over 3. Then, when you calculate the total of all these values, that is going to be 5 over 24. So that is the exact area, exact value of this integration. Okay, for question number 7, the diagram shows a curve y equals to 4 cos half x and y equals to 1 over 4 minus x, whereby the x is from 0 to 4. Now, when x equals to a, this is the a, the tangents to the curves are perpendicular. Okay, so it means that this is the, obviously, 4 cos half x. This is 4 cos half x. Okay, because a cos graph always in this shape, right? This is a cos graph. And then the other one is y equals to 1 over 4 minus x. Now the tangents, so it means that at this point, okay, tangent always touches the point, just touches. So my graph is not very accurate, right? And then the other point here, the tangent at a, x equals to a, that means here, okay, so they are 90 degrees because of perpendicular. Now I need to show that a equals to this expression. Okay, so what to do is, tangent means, the gradients of tangents means dy over dx. So it means that now for both dy dx, I need to consider perpendicular. So what to do is, you just find the dy dx for both graphs first. Okay, then from here, when I differentiate, I will get dy over dx, keep the 4. Now, when you differentiate cos mx plus b, so differential cos is basically negative sign. Rewrite the mx plus b, and then when differentiate mx plus b, that is m. So this is our differentiation. Okay, so therefore, I will just write differential cos minus sine, rewrite the half x, differential half x, this is half. So from here, I will simplify it into minus 2 sine half x. That is my first gradient of tangent. Okay, but then it's mentioned at a. So now, at a, dy dx, just replace the x by a, it will be negative 2 sine half a. And let this be the first equation, because this is a tangent of the first curve. And then now, for the second graph, so y equals to 1 over 4 minus x. Then here is degree 1, so I can move up. It becomes 4 minus x degree minus 1. That means now my dy over dx, bring down the negative 1, rewrites the whole function, the degree becomes minus 2. Okay, because our formula here, d over dx, fx degree n. This is the power rule that I have mentioned just now. So here will be n fx degree of n minus 1, and then followed by f prime x. So that's why I'm getting minus 1, and the power becomes minus 2 right now. That is the first part. And don't forget to differentiate the fx. So when I differentiate 4 minus x, that is minus 1. Okay, and now here we write. So the minus and minus 1 becomes positive 1, and because of the negative degree, I will move down the whole term. That is x minus x, 4 minus x squared outside. And then same case as just now, when x equals to a. Okay, I need to find out what is the gradient of tangent. So this is going to be 1 over 4 minus a squared. Now, it's mentioned that they are perpendicular to each other. So if you still remember, if two lines are perpendicular to each other, means that m1 times m2 equals to minus 1. The product of the gradient will be minus 1. So I'm going to use this concept to solve this question. So now, right, so first times second, it will be minus 1. That means minus 2 sine half a equals to, times one over 4 minus a squared equals to minus 1. Okay, now when you look at the answer here, you need to get the a as a subject. The term with the sine half a will be on the other side, which means, okay, so I will be moving this to the right side. Okay, that means you will be getting minus 2 sine half a equals to negative of 4 minus a squared. Then the negative will be cancelled off from both sides. Then now I will move the square to the other side. So when I move the square to the other side, that is basically plus minus square root. So I will write 4 minus a is plus minus square root of 2 sine half a. Okay, now look at the condition. Your x is between 0 and 4. Right. So x between 0 and 4. So that means now your a, alright, your a is part of the x is between 0 and 4 as well. So which means here your a is also between 0 and 4, but cannot be 0 because obviously your a will not be 0. So here I will cancel the equal sign. Okay, it will be greater than 0. Right? Then from here, obviously the a will not be negative. Okay, so when you substitute into this value, so since your a is less than 4, I will say that since your a is less than 4, so 4 minus a will be greater than 0, right? So then from here, you can just write a is less than 4, therefore 4 minus a will be greater than 0. So since it's greater than 0, I will say that 4 minus a is positive square root because it is positive value. Okay, and now we look at the answer here. We need to get the a as a subject. So the first term is 4. Then you minus the square root. So it means that this whole term, the minus a will be moved to right side, and then the square root will be moved to the left side. That means here I will be getting a equals to 4 minus square root of 2 sine half a. So that is the solution of this question. Alright, so done for this question. Now, part 2, verify by calculation that a lies between 2 and 3. Okay, so I will verify this using the sign change rule. So it means that I will refer back to the previous expression and get right side be 0. So it means that I will move all the terms on right side to the left side. So then a minus 4 plus square root of 2 sine half a equals to 0. This is from first part. Right? Then from here, I will define my left hand side as FA. So FA equals to a minus 4 plus the square root. This is my function of a. And now, to show that a lies between 2 and 3, just replace the a by 2 and 3. So now, when you calculate this value, okay, make sure it is in radians mode. right? Because you are counting sine 1. There's no degree here. Therefore, you'll be getting negative 0.703, which is less than 0. And well, f3, that is going to be 3 minus 4 plus square root of 2 sine half times 3. Okay, then you will be getting 0.412. That is greater than 0. So then from here, I will just write, since f2 less than 0 and f3 greater than 0, there is a sign change. Hence, A lies between the two values. Okay, so done for this question. Okay, part 3. Use an iterative formula based on the equation in part 1 to determine A correct to 3 decimal places. Give the results of each iteration to 5 decimal places. Okay, so from A. From first part, not from A, from first part. The A just now, okay, go back to the formula. Take this A, and since we need to form the formula, we need to add the subscripts n plus 1 to the left side and the n to the right side. Okay, just added to the A. So here will be 4 minus square root 2 sine half A, but then add on the subscripts. So for the left hand side, it will be A of n plus 1. And now, in previous parts, we have proven that it's between 2 and 3. So you can take A not as 2 or 3 or any other values. So I will just make it as 2.5. That is the middle value. Okay, so you can take any values up to you. So A not be 2.5. Then I will get A1. That is 4 minus square root of 2 sine half times 2.5. Okay, then now look at here. 5 decimal places, final answer 3 decimal places. So then remember to calculate all this using radians mode. Then you will be getting 2.62233. So that is our A1. Now for A2, just replace the A1, the A1 by the previous value. So that will be 2 sine half of 2.62233. And then you will be getting 2.60960. Okay, same goes to the A3. Now, when to stop this iteration, it depends on here, 3 decimal places. So make sure you get 3 same decimal places. Obviously, they are not the same, then you have to continue. Then this is going to be 2.61087. Okay, so A4, that is 4 minus square root 2 sine half 2.61087, and this is going to be 2.61076. So then now here, these 3 are the same. Okay, final answer depends on the the next value. Since this is greater than 5, therefore we round up. Okay, so then my A approximate to 2.611. That is my A value. Okay, question number 8. Given the fx is a rational function. First part, express fx in partial fractions. So 16 minus 17x over 2 plus x times 3 minus x squared. Okay, first of all, you must check whether this is proper or improper rational function. So look at the degree x in the numerator, that is degree 1. Okay, but then for the denominator, this is squared, and here is degree 1, therefore it is degree 3 for the denominator. That is the highest degree. So I will classify this as proper rational function. So if you are given proper rational function, means that you can just direct find the partial fractions. So now, first factor is 2 plus x. This is a linear factor. Therefore, my numerator is constant. Then the next one is square of 3 minus x. 3 minus x is a linear factor, but it is repeating because of squared. I will start with 3 minus x degree 1, followed by 3 minus x degree 2. Okay, then the numerator will be b and c. Then now here, to get the unknowns a, b, c, in order to get the partial fractions, we need to always compare with the left side. So then here, for the first term, I need to multiply with 3 minus x squared, so that you will always get the same denominator. So for the second term, since you are given x 3 minus x, so I need to times with 2 plus x and 3 minus x, so that the denominator will be the same. Okay, and same goes to the last term. You are given 3 minus x squared, so I times with 2 plus x. So after this, you just need to compare the numerators, because all the denominators are same factors right now. Okay, so basically you can just ignore the denominators. That means now here I will be getting 16 minus 17x. The right hand side will be all the numerators. Okay, now to get the ABC, the three unknowns, always let the factor be 0. I'm using the substitution method. So you may use the expansion method. Okay, after you expanded the functions, then you just compare the coefficients. So here I'm using substitution method, means that I let x minus 3 be 0. Then my x will be 3. So now you substitute 3 into the left and right side. 16 minus 17 times 3. But from the right hand side, whenever you see 3 minus x, this term will be 0. So it means that you can't find the a, you can't find the b, because both multiplied with 0. Then you are able to find the c. So equal to c bracket 2 plus 3. So for the left hand side, you will be getting negative 35. Right hand side is 5c. Hence your c is minus 7. Now, next term is to let 2 plus x be 0. So it means that for the last term, you can't find the c because c multiplied with 0. That means you are able to find the a right now. So it means that now I let 2 plus x be 0. Then my x is negative 2. Okay, then now just replace x by minus 2. So it will be 16 minus 17 times minus 2 equals to a times 3 minus minus 2 squared. So for the left hand side, that is going to be 50. Okay, right hand side will be 25a. Then from here, my a is 2. So once you found the c and a, there's no more other factors on the right side. What to do is just let x be any other numbers. I let it be 0. So when x goes to 0, left hand side 16 minus 17 times 0 equals to a. Okay, a is replaced by 2. 3 minus 0, I'll get 3. 3 squared. Then plus b. b is unknown. Just rewrite the b. Then now substitute into here. 2 plus 0 is 2. 3 minus 0 is 3. Then plus c. c is minus 7. After that, 2 plus 0 is 2. So I will be getting 16 equals to, this is 9 times 2, 18. Then plus 6b minus 14. Which means my 6b, okay, so it will be 16 minus 18 plus 14. And then you will be getting 12. So 6b is 12. Hence the b is 2. Once you have found these three unknowns, okay, a, b, and c, substitute back into your general form to get the partial fractions. So I will be getting 16 minus 17x over 2 plus x times 3 minus x squared. That is going to be a over 2 plus x. So my a equals to 2. So this is 2 over 2 plus x. Then plus b over, b is also 2. 3 minus x. Then plus c. c is minus 7. So you just write minus 7 over 3 minus x squared. So that will be my partial fractions. Okay, part 2, hence. Hence means use the previous answer. Obtain the expansion of fx in ascending powers of x up to and including the term in x squared. Okay, so now here, I will just rewrite 2 over, so your fx is 2 over 2 plus x plus 2 over 3 minus x minus 7 over 3 minus x squared. Okay, so from here, if you want, you can just expand one by one and then you combine all three. So probably I'll just expand one by one. So 2 over 2 plus x, this is basically 2 times 2 plus x power negative 1. Now for information, the binomial expansion, it must be 1 plus x degree n. Then it will be 1 plus nx plus n times minus 1 over 2 factorial x squared. Okay, and so on. So the condition for you to use this binomial expansion is it must be 1 and plus. So now we are getting 2, and even though it's plus, so it means that I need to make the 2 to be 1 by factorizing the 2. So I factorize 2, then it will be 1 plus x over 2, and then all this degree minus 1. And then now we have a formula AB degree m, that is a degree m, b degree m. Means that this minus 1, you bring it in to the square bracket. So I will be getting 2 times 2 power negative 1, then 1 plus x over 2 to the power of negative 1. Alright, so 2 times 2 power negative 1 is basically 1, because the 2 power negative 1 is 0. Right? 2 power negative 1 is half. So 2 times half is 1. Sorry about that. So here is basically 1 plus x over 2 power negative 1. And now I can just do the expansion using this binomial expansion formula. That is going to be 1 plus n, x becomes x over 2. Then plus, so my n is minus 1. Therefore, it becomes minus 1. Then n minus 1 becomes minus 2 over 2 factorial. Then x over 2 squared. Okay, and then from here, when you simplify, there is 1 minus x over 2 plus x squared over 4. Now, same goes to the next one. So 2 over 3 minus x. This is 2 times 3 minus x degree minus 1. Okay, with degree of minus 1. And then, again, take out the 3. Okay, let me check the space. Alright. So, factorize the 3. So you will get 1 minus x over 3 to the power of negative 1. So the power of negative 1, you bring it in. It will be 2 times 1 over 3. Because 3 power negative 1 is 1 over 3. Okay, then 1 minus x over 3 power negative 1. So therefore I will get 2 over 3. Then I'll do expansion. 1 plus nx, right? So the n is negative 1. The x now becomes negative x over 3. Because for your information, it's supposedly like this. So I have to write a plus and then a minus. Right? So here, I write a plus. Then put a minus. Okay, so therefore the next one is minus 1 minus 2 over 2 factorial, then minus x over 3 squared. Right, then now here you will be getting 2 over 3 times 1 plus x over 3, then plus x squared over 9. So lastly, you will be getting 2 over 3 plus 2 over 9x plus 2 over 27x squared. Okay, now last term, you are getting 7 over 3 minus x squared. Later I will minus. So I will write 7 over 3 minus x squared. This is going to be 7 times 3 minus x to the power of negative 2. So from here, again factorize a 3. And the power negative 2 bring it in. That will be 3 power negative 2. Then 1 plus negative 3 over negative x over 3. Power negative 2. So 3 power negative 2 is basically 1 over 9. Okay. Then here it will be 7 over 9. 1 plus minus 2 times negative x over 3. That is my nx. Plus minus 2. So minus 2 minus 1 is minus 3 over 2 factorial. Then minus 3, x over 3 squared. So from here, you will be getting 7 over 9 multiplied with 1 plus 2 over 3x plus 1 over 3x squared. Okay, at last, you are getting 7 over 9 plus 14 over 27x plus 7 over 27x squared. Okay, lastly, the expansion. It will be the first expansion plus the second minus the third expansion. Okay, so I will just rewrite 1 minus x over 2 plus x squared over 4. Then you plus with the second expansion 2 over 3, 2 over 9x. Plus 2 over 27 x squared. Then minus the third expansion, minus all these terms. So minus 7 over 9 minus 14 over 27x minus 7 over 27x squared. Okay. Now here, when you simplify, so 1, look at here, 1 minus 7 over 9 plus 2 over 3. That is going to be 8 over 9. Therefore, the term with the x, we'll get the total. It will be negative 43 over 54x. Lastly, you will be getting 7 over 108x squared. So this will be the expansion up to x squared. Okay, question number 9. The diagram shows a set of rectangular axes, OX, OY, and OZ, and 4 points A, B, C, D, with position vectors. OA is 3i is given here. Then OB is given, right? OB is given, and then OC given, and OD also given. Okay. Now, First part, find the equation of the plane BCD, giving your answer in the form ax plus by plus cz equals to d. Okay, so now for the equation of the plane, basically we need to know, okay, let's say this is a plane. There's a normal vector. This n is perpendicular to whole plane. Alright, so now I will rewrite first. My OA is 3, 0, 0. So the equation of the plane is actually moved to the further mathematics. Right, so from here I will still solving all this. So the B 3i plus 4j is 340, and then the OC is basically 1i plus 3j, which is 130, and then the OD will be 2i, 3j, and 5k, 235. Okay, so I will let my n be ABC. So I need to find out what is my r dot n equals to a dot n. So firstly, I need to find out what is my n. The n is the perpendicular vector, the normal vector to the plane. So from here, I know that, right, since ABC, you need to find plane BCD, plane BCD. Okay, this is a plane. Right, that means your plane consists of vector BC. Okay, say that is BC and also BD. Right, so in other words, this is a plane. Here you have BC and this is BD. Right, then my n is perpendicular to both vectors. So that's why I need to find out the vectors BC and BD. So then from here, my BC equals to OC minus OB. That is 130 minus 340. And this is going to be minus 2 minus 1, 0. And then next is to get the BD. Okay, vector BD. Vector BD is basically OD minus OB. This is going to be 235 minus 340. And then you will be getting minus 1, minus 1, 5. And now since both also perpendicular to the vector n, that means I can just use the scalar product formula. Okay, so BC dot n equals to 0. So then you will be getting minus 2 minus 1, 0 dots with ABC. Now my purpose is to find the values of ABC. So from here, I will be getting minus 2a minus b plus c equals plus 0, c equals to 0. So no need to write that. So from here, my b equals to minus 2a. That is the scalar products formula. Means that you multiply all these components, then you plus all together. Okay, then from here, I know that my BD dot n also 0. Then I will be getting minus 1, minus 1, 5 dots with ABC equals to 0. That means now my second equation, it will be minus a minus b plus 5c equals to 0. Okay, this is my second equation. Now to solve the ABC, the vector n, I will substitute first equation into second equation. So you will get minus a minus, the b is replaced by minus 2a. After that, plus 5c equals to 0. So for the first two terms, minus a plus 2a, that is going to be plus a. So a plus 5c equals to 0. Now, basically from the first equation, I know that my b depends on a. Okay, then from here, then from these results, I will say that my a equals to minus 5c. So my a depends on c. So I can just let my c be t, any other numbers, because you will be getting infinite solution. You only get 2 equations, but you have to solve 3 unknowns. Therefore, that is considered infinite solution. So as long as I let my c be any numbers, let's say t, then I'm able to get my a. My a will be minus 5t based on this result. And then from the first equation, my b is minus 2a. So minus 2 of minus 5t, that is 10t. Okay, so from here, I know that my n is going to be A, B, C. So it will be factorized as T. So my A is minus 5, my B is 10, and my C is 1. That means I can say that my N is basically parallel to this vector. Okay, so my N is basically minus 5, 10, and 1. And now for the equation, okay, so probably I just continue here because of not enough space. So the vector equation, or the question says Cartesian equation, probably I will just write equation of the plane. So equation of the plane, we use r dot n equals to a dot n. Okay, so now r is replaced by x, y, z. The n already found, minus 5, 10, 1. That is equals to the A. A is any points on the plane. So just now we have 3 points on the plane. Okay, let me rewrite this. So this is going to be equals to, you can take any points because now you are forming BCD. So you can take points B, point C, or points D, up to you. Okay, so it means that now I'm taking points B. Okay, I will take points B, 3, 4, 0. So here will be 3, 4, 0. Dot with minus 5, 10, 1. Okay, so probably I'll just draw a line here. Right, then from here, now for the numeric, for the left hand side, this is a dots product, just multiply and plus all together. So you will get minus 5x plus 10y plus z. Then for the right hand side, just do expansion. So 3 times minus 5 plus 4 times 10. Okay, then from here, at last, I will be getting minus 5x plus 10y plus z equals to minus 15 plus 40. That is 25. So this is your vector equation of the plane. Or this is the Cartesian equation of the plane. Okay, now part 2, find the acute angle between the planes BCD and OABC. Okay, so plane BCD, we already found the n, the normal vector. So now we need to find for the OABC. So it's the same method, right? So for plane OABC, I will just write let n2 be ABC. Okay, so again, now look at here. Let's say this is the OABC. It's a plane. So now you will have OA, okay, and then you will have OB, right? OB, because your plane has OABC, then it will be perpendicular to the N2. Right? So both vectors will be perpendicular to N2 as well. So now here I will write OA dot N2 equals to 0 because our purpose is to get the N2. So now your OA from the previous working, 300 dot ABC equals to 0. Therefore, 3A equals to 0. So I know that my A is 0. Okay, now next is I will get OB. So here OB dot N2 equals to 0. So the OB is given in the question 340, right, which is here. So 340 dot ABC. Therefore, I will be getting 3A plus 4B equals to 0. Then remember, just now the A is 0. Okay, so from here, from first, my A equals to 0. That means my B equals to 0. So if a and b equals to 0 and you are not able to find the c because of the 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 z component for the OA and OB are both 0, that means I would say that my c is basically any numbers. So my c is s. Okay, therefore my vector n2 consists of ABC, that is 0, 0, s. Then I can just factorize the s. That will be 0, 0, 1. And then I will say that my n2 simplest form will be 0, 0, 1 because the s is any numbers. Alright, so now to find the angle between two planes, that is basically scalar products formula. So let theta is the angle between planes BCD and OABC. So n1 dot n2 equals to magnitude n1 magnitude n2 cos theta. Okay, so the m1 just now from here, from the previous question, minus 5 tan 1. So here minus 5 tan 1 dots with the n2 we have just found 0, 0, 1. Then the magnitude is square root of sum of each components, sum of square of each component. Then from here you will get left hand side is basically 1 because the first two terms multiply by 0. Then for the right hand side you will be getting 5 squared is 25. 25 plus 100, so 125, then plus 1 is 126. So this is going to be square root of 126. Then for the other term, square root 1. Then from here, cos theta is basically 1 over square root of 126. Then now my theta is going to be inverse cos of this value. That is 84.9 degrees. Okay, so that is the angle between two planes. Now, next question. Throughout this question, the use of calculator is not permitted. The complex number square root 3 plus I is denoted by U. Firstly, express U in the R, E, I theta, where R is greater than 0, theta is between minus pi and pi, inclusive pi, giving the exact values of R and theta. First part. Hence, or otherwise, state the exact values of modulus and argument for U degree 4. This is the second part. Okay, so U is square root 3 plus I. To get the R and theta, R is the modulus. So we know that R is modulus U. That is square of the real part plus square of imaginary part. So the real part is square root 3, the imaginary part is 1. That means you'll be getting square root 4. That is 2. So for the theta, we need to sketch the Argand diagram. The real part is square root 3. Your imaginary part is 1. So this is your angle. This is my real axis. And this is my imaginary axis. Okay, so obviously the theta is argument of the complex number that is inverse tangent 1 over square root 3. Because it looks like a right angle triangle. Okay, to get the theta, it will be 1 over square root 3. Then here, from here, I will be getting my exact value. Inverse tangent 1 over square root 3 is basically pi over 6. Therefore, my U is 2e pi over 6i. Okay, you need to get I theta, so I pi over 6. You can just change to this form. So done for the first part. Hence, state the exact values of modulus and argument for U degree 4. Okay, for U degree 4, modulus of u degree 4 is basically r degree 4 because you multiply itself. Therefore, it's 2 power 4 and you are getting 16. Then the argument of u degree 4 is basically you are adding the argument for 4 times. There is 4 times argument of u. Then I will get 4 times pi over 6. And this is 2 over 3 pi. So done for this part. Okay, let me check. Oh, here, part 2. Okay, part 2. Verify that u is a root of this equation and state the next complex root of this equation. So this is the first part. Now to verify means that it satisfies the equation. Means that when I replace the z by the u, the result is 0. Okay, so your u just now square root 3 plus I. So z cubed plus, minus 8z plus 8 square root 3. So just replace now. Square root 3 plus I cubed minus 8 times square root 3 plus I plus 8 square root 3. Okay, so for the cube, we need to do expansion. That is the Pascal triangle. Okay, if you heard this before. So we know that a plus b degree 0 is 1. So the coefficient is 1. A plus b degree 1, I'm getting a plus b. The coefficients will be 1 and 1, 1a and 1b. So the next one will be 1 and 1, and then the middle term is 2. Because a plus b squared, you are getting a squared plus 2ab plus b squared. So the coefficients will be 1, 2, and 1. So I know that when it is degree 3, just add on 1 in front and at the back. So just plus together 3 and 3. So which means for a plus b cubed, I will be getting a cubed plus, because here 1, right? So the next is plus 3 a squared b plus 3ab squared plus b cubed. This will be my expansion. This is what we call as Pascal triangle. So here I will just write square root 3 cubed plus 3 times square root 3 squared I plus 3 times square root 3, then I squared plus I degree 3. That is my expansion. Now next, this minus 8 times into the bracket. You will get minus 8 square root 3, then minus 8i plus 8 square root 3. Then from here, the minus 8 square root 3 and plus 8 square root 3 will be 0. Okay, then for the first one, cube of root 3, that is same as 3 root 3. And then 3 times root 3 squared, this is 9. Then copy the I, 3 root 3 I squared. Okay, now for your information, I squared is minus 1. Okay, so here I will change to minus 1. And then what happened to I cube? I cube is going to be I squared times I. That is minus 1 times I. Then I will get minus I. This is going to be minus I. So at last, I will be getting, this is minus 1. And then minus I. And don't forget the minus 8i at the back. Then from here, right, I will be getting, okay, 3 square root 3 plus 9i minus 3 square root 3 minus I minus 8i minus 9i. So obviously this is 0. Therefore, u is a root of the equation. Okay, now to state the other complex root. Now, when you look at the equation over here, these equations with all constant or real, I would say with real coefficients, because here is 1, this is minus 8, and this is 8 root 3. Okay, there's no complex numbers. Therefore, the other complex roots, it will be the conjugate of the u, that is square root 3 minus I. Okay, done for this part. Now part 3. On a sketch of an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities modulus of z minus u less equals to 2 and IMZ. The IM is basically the imaginary part of the z. Okay, so now modulus z minus u less equals to 2. This is modulus of z minus square root 3 plus I less equals to 2. Now basically this is a circle with center, square root 3 and 1, because the coefficient, the imaginary part is 1 for the complex number. That complex number is basically the center, okay, and radius is 2. But now because of less equals to 2, if this is equal sign, that will be the circumference of the circle, but less equals to 2 means that it's also including the region inside the circle. So I'm going to draw or sketch a circle later on. So for the IMZ, greater equals to 2. So normally for z, it will be x plus yi. So then from here, I know that the imaginary part is going to be y. Therefore, the y is at least 2. Okay, now we need to sketch a circle. Probably I'll sketch a circle first, then I will adjust. Okay, this center is square root 3 over 2, square root 3 and then 1. And then the radius is 2. Since this is 1, square root 3 is basically 1 point something, right? Less than 2. So that means here is going to be, okay, here is 1, that means here is 3. Okay, so here is what? Square root 3. Square root 3 plus 2. Right, so then I have to find out here supposedly 1. Then this is 2. Okay, so this is y equals to 2. This is real part. And here is imaginary part. Okay, then now here is 0. So let me check the value first. Square root 3 is basically 1.73. So when you minus 1, this is negative, okay, square root 3. This is negative 0.2. Okay, so here. So here I only simply slash, right? Please measure. Then here is square root 3 minus 2. Okay, now when you look at the interval, the inequalities, y is at least 2, means above the line, but this is less equals to 2. Less equals to 2 means that it will be inside the circle. So obviously the region is over here. Okay, I need to find out when x equals to 0, whether my y is positive or negative. So because I just simply sketch, so quickly do a checking here because I just simply sketch, right, when x is 0. So I substitute into here, my z will be x plus iy, then minus square root 3 minus I need to find out what is the magnitude. So here yi minus square root 3 minus I. Okay, so for the circle with 2, let's say here is 2, it will be, okay, here, just for information, this part no need. What you need to do is you try to sketch, right? You measure and sketch. Make sure label correctly. Okay, because here I only simply sketch, so I'm not sure whether this point is on the positive value or negative value. So here I will not do the checking. You guys please draw the Argand diagram using ruler. Right, you measure. Alright, so basically the rough idea is like this. Okay, so done for this question. Alright, so now here, since we have completed the whole paper and also it has come to the end of the video, thanks for watching. If you enjoy watching my video, please like this video and subscribe to the channel, and also share this channel with your friends, and stay tuned for more upcoming videos. Thank you everyone. Bye.